Welcome to homework.
Given an equation in which phosphoric acid reacts with calcium hydroxide to form a new compound, hydroxyapatite, we first need to write the balanced equation. And it's important to note that this is an acid reacting with the base. So in addition to the compound formed, we also form water. Once we know that, we can write what's called the skeletal equation, or formulas instead of words. Phosphoric acid is H3PO4. Calcium hydroxide is made up of the calcium ion, which is a +2 charge, and the hydroxide anion, which is a -1 charge. To make a neutral compound, we need 2 hydroxides for every calcium. So the formula is CaOH2. You're given the formula for the new compound, Ca5PO4 3OH, and of course water is H2O. Once you have your skeletal equation, we can balance by changing the coefficients. On the product side, there are 5 calciums, so we need to multiply on this side by 5. There are also 3 phosphate ions and only 1 here, so we multiply by 3. This gives us a total of 10 oxygens plus 3 more, or 12. So 22, whereas on this side, we have 12, 13, and 1 more. So we need to multiply this by 9 to get the correct number of oxygens. You can then see that you also have the correct number of hydrogens, because here you have 9 plus 10, and here we have 18 plus 1. If we have the balanced equations, we can find the amount of product formed. Since both amounts of reactants are given, we need to identify the limiting reagent. The limiting reagent is the reactant that produces the smaller amount of product. So in this case, we have 100 grams of 85% phosphoric acid. This is equivalent to 85 grams. And we have 100 grams of calcium hydroxide. To find the amount of product formed, our first step is to change to moles. And we do this with molar mass of phosphoric acid. Which will come from the periodic table. Once we have moles of phosphoric acid, we can change from one substance to another and find moles of our compound. Using mole ratio balanced equation. Only once we have moles, we can find grams or mass. Using the molar mass of our compound. Then the same steps with calcium hydroxide, converting to moles. And then converting to moles of product. and then finally grams of product. And again, whichever produces the smaller quantity is called the limiting reagent. It's helpful to find the molar mass of each before we start. So if we look at our molar mass of phosphoric acid, we know that it's equal to 3 times the molar mass of hydrogen, which we find on the periodic table, plus the molar mass of phosphorus, plus 4 times the molar mass of oxygen, or 1 mole of phosphoric acid equals 97.994 grams. Similarly, we find the molar mass of calcium hydroxide to be 74.092 grams. And finally, our product has a molar mass of 502.307 grams. So starting off with 85 grams of phosphoric acid, we change to moles by dividing by the molar mass. And then multiply by the molar ratio, putting our number of moles of product on top. So 1 mole of CA5, PO43, OH, for every 3 moles of phosphoric acid. And again, that comes from the coefficients of the balanced equation. And then finally, we multiply by the molar mass of our product. So the phosphoric acid will produce 145 grams. If we look at our calcium hydroxide, 100 grams, following the same steps, first changing to moles by dividing by the molar mass, (74.092), and then using our balanced equation to convert to product, 1 mole of CA5, PO43, OH for every 5 moles of calcium hydroxide. And then finally multiplying by the molar mass of the product. Equals 136 grams. The smaller amount is produced, so the final answer is 106 grams.